Alright, this is problem number 8. This was the rocket problem. As far as the free response questions go, this one should have been the most straightforward and least difficult of the problems that you were given. The problem states, a rocket initially at rest is fired vertically upward with an acceleration of 12 meters per second squared. At an altitude of 1 kilometer, the rocket engine cuts off. Air friction is negligible in this problem. Part A. How fast is the rocket traveling when the engine cuts off? So let's draw a picture for a moment. Okay, here is our rocket. Okay, it is blasting off. Its initial velocity, we are told, is 0 meters per second. And the rocket blasts off and magically changes colors. And the engine cuts off at an altitude of 1 kilometer. So right here we are at 1 kilometer, which, remember, 1 kilometer equals 1,000 feet. Now, we are told the acceleration is 12 meters per second squared, and we are asked to find V final at rocket engine cutoff. So, this is part A. Let's remember the equations that we have. This one is the same equation for pretty much every part of this problem. So we have V final squared equals V initial squared plus 2AD. D we are given to be 1,000 feet. Acceleration is 12 meters per second squared. Initial velocity is 0. V final equals plus minus the square root of 0 squared plus 2 times 12 times 1,000. Alright, that equals plus minus 155 meters per second. Right, remember the rocket is going up, therefore we choose the positive one. And that's it. And that was part A. Part B says, what maximum height relative to the ground does the rocket reach before it begins to fall back towards the Earth? So if we look back up to our original picture right here now, okay, the velocity of this thing is 155 meters per second. Right? So that initial velocity, which I called final accidentally, that initial velocity must now be taken from 155 meters per second down to 0 by gravity before that rocket begins its fall back to Earth. So let's look at what we need to figure this problem out. Alright, so here's what we know. Our initial velocity from part A was 155 meters per second. Our acceleration is 0 meters per second squared now because the engine is gone. That was acceleration due to the rocket engine. But what is our acceleration? Okay. Our acceleration is gravity, okay, or negative 9.8 meters per second squared. V final at the top is 0. And I am looking for delta x. How high did the thing go? Delta x, delta y, whatever you think about it. Okay, same equation as in part A. We're just going to rearrange it a little bit. So if I solve it for d, okay, I get d equals v final squared minus v initial squared becomes 1,225 meters. Now, that is how far the rocket flew between the engine cutting off and it stopping at the top. It is not its total height. So its total height, the delta x total, is the 1225 plus the 1,000 equaling 2,225 meters above the ground. Done. Pretty bad. Let me stop this and I'll do part C and